On your inverses day 1 homework, I'm going to help you out with 3 different problems. In this first set, let's start with set C. We are finding the inverse of the table, and to find the inverse of the table, all you have to do is switch the x and y values. The x stays in the same place, the y stays in the same place, but the values switch. So the y values were 3, 10, 5, and 2. Those are going to be the x values. The x values were 1, 2, 3, 4. Those will be the y values. This is the inverse function. We're done. For a graph, to find the inverse function, we need to just take each point and switch the x and the y values. This point was 2, negative 2. So when we switch the x and the y value, the new point will be negative 2, 2. This point was negative 5, 1. So the new y value will be, new point will be 1, negative 5. We've switched the x and the y values, and since this was connected to this, we're going to connect it. Next, 3, 2 becomes 2, 3. And remember, it's connected to this one. It was connected to negative 5, 1, so now it's connected to 1, negative 5. And finally, 5, 9 becomes 9, 5. And remember, we should always notice at the very end that if you draw the linear parent function, the inverse function should be a reflection across. And you can see that. If we reflected this, it's a mirror image across that line. The last one I'm going to do is on the back. Number 5, it asks us to find the inverse by switching the variables and then solving for y. So this is our original function. I'm going to, actually I think I'll do number 6. I think you'll have more trouble with that one. The original equation was y equals negative 1/2 x. I'm going to switch x and y. I've found the inverse. Oops. Y becomes x, x becomes y. Everything else stays in the same place. And now all I have to do is solve for y. I need to subtract 3 first. And remember, to get rid of a fraction, it's multiplying by negative 1/2, so we need to divide by negative 1/2. When you divide by a fraction, that's the same as, I'm going to scratch out here and show what it's the same as. It's the same as multiplying by the reciprocal, negative 2 over 1. And if we multiply by negative 2 over 1 on this side, we need to multiply by negative 2 over 1 on this side. Now negative 2 over 1 is just negative 2. So I'm multiplying by negative 2 on both sides. Here, I need to distribute because it's a number times a binomial. So it's negative 2x plus 6. Negative times a negative is a positive. Over here, negative 2 times negative 1/2 is positive 1, and we just end up with y. So our inverse function is y equals negative 2x plus 6. Now it's said to graph both the function and its inverse. So the original function had a y-intercept at 3. This was the y-intercept. And the slope is negative 1/2. So for every 1 it goes over by 2. Down by 1, over by 2. Down by 1, over by 2. When we go backwards, it's up by 1 to the left by 2. Up by 1, left by 2. I think that's enough. So there's a continuous function. All the in-between x values make sense, so we can connect the line. We're also going to graph the inverse function, y equals negative 2x plus 6. The y-intercept is 6, so we're going to put that on the y-axis. The slope is negative 2. Negative 2, that's the same as negative 2 over 1. It means it's going down by 2 for every 1 you go over. Down by 2 for every 1 you go over. Down by 2 for every 1 you go over. And just as on the front page, we see that if we draw the linear parent function, y equals x, as a dotted line, you can see it nicely reflected across. It's symmetric on both sides. There is a mirror image here. It looks like a butterfly, but it's reflected across. It's a good way to check and see if you messed up. If it doesn't come out to be reflected across the linear parent function, it means you made a mistake. I hope that was helpful.